Hello, everyone. Welcome back. My name is Jibril Anifowoshe. Today, we're building something that's simple, secure, and enterprise ready. I'll walk you through how to provision a mini enterprise infrastructure in Azure using Terraform, exactly how a real DevOps or security teams will do it. So basically, code driven, repeatable, and cloud native. We'll stand up two key components: a network foundation that defines our private IP space and segmentation, and a secure cloud storage layer that can later feed logs or SIEM data, all within Azure's free tier with no compute cost and nothing exposed to the public internet. And to make it more relatable, I'll also point out AWS equivalents along the way. So whether you think in Azure or AWS terms, you see exactly how this concept align. So to get started with setup, first you need an Azure free tier account to essentially give you that credit and resource limits to follow along without having to spend anything. And the next thing, we'll set up the environment by installing Terraform and then Azure CLI and lastly VS Code. So since I'm on a Mac OS, I'll be using Homebrew to install them, but if you're on a Windows or Linux, the commands are just as straightforward. So to break it down a little bit further, Terraform is our provisioning engine. So basically, it's what's going to define and deploy the infrastructure as a code. And the Azure CLI essentially handles the authentication and lets Terraform talk to Azure securely. And the VS Code brings everything all together. It's our editor, the terminal, and the workspace all in one place. So once we launch VS Code, let's talk about the repo structure. This project is intentionally lightweight. Everything lives inside a single Terraform file called the main.tf, and it's stored in the folder called the Azure Mini Infrastructure as a Code demo. So think of this file as your blueprint. It's where we define every part of our infrastructure, the network, the subnet, and the storage. In an enterprise environment, this is exactly how a team start. You codify your infrastructure once, you version it with Git, and you can deploy it anywhere, development, staging, production, all from one same source. All right, so let's dive into the architecture we're building and walk through the main TF line by line. We start at the top with the Terraform block itself. This section tells Terraform two things: what version Terraform this file support, in this case version 1.5 or higher, and which providers it depends on. Here we declare the Azure RM provider for Azure and a lightweight random provider for generating unique names like suffixes or storage accounts. Think of this block as a manifest for your project. It essentially defines what Terraform tools and plugins it needs before it can do anything else. And if we're deploying this same setup on AWS, you'd just swap the Azure RM for AWS. Same syntax, same logic, just a different cloud. That's the beauty of Terraform. It's completely cloud agnostic. So this next section defines our variables and locals. It is what make the configuration reusable and portable. Here we've set the location to East US and the project name to Mini Infrastructure as a Code Azure Demo. I also sanitize and shorten the name because Azure storage accounts enforce strict naming rules, basically lowercase only and globally unique. And if you've worked with AWS S3, same idea applies. Every bucket name must be unique worldwide. So now let's get into the fun part, provisioning the network layer. It starts with the resource group, and I want you to think of it as your logical folder in Azure. It's how resources are grouped and managed together. And in AWS term, you can think of it like a cloud formation stack or a project namespace. Next is the virtual network or VNet. This essentially defines your private IP space. Here we are using 10.10.0.0/16, meaning that it supports about 65,000 IPs. And if you're coming from AWS, this is your VPC and it serves the same purpose, just different cloud. So inside of that, I carve out a smaller subnet. 10.10.1.0/24. And this subnet is essentially isolating workload and limiting threats around lateral movement. It is a fundamental security concept. In a real environment, your compute, databases, or applications would live here safely segmented. Then comes the Network Security Group, or NSG, basically Azure's built-in firewall. I've added two sample rules for port 22 for SSH and port 80 for HTTP. Now, these are purely demonstration. In production, you'd probably lock port 22 to your own IP, or use Azure Bastion or just-in-time access. And instead of HTTP port 80, you'd enforce HTTPS port 43 with a valid SSL certificate via a load balancer or application gateway. So since there's no VM attached here, this ports are just here for illustration purposes to show how access control work in a real setup. Next, we have the storage layer. This is where logs, artifact, or SIEM data could live. It begins with a storage account, which is Azure's equivalent of AWS S3 boundary. I name it dynamically to guarantee uniqueness. Then I set it to standard LRS, that is locally redundant storage, meaning 3 synchronized copies within the same data center. I believe it's reliable, but still free tier friendly, perfect for this demo. From there, I disabled public access to ensure no one can directly query blobs. I enforced TLS 1.2 for encrypted connection and enabled versioning as a safety net against accidental overwrite. Inside that account, we created a blob container called logs. That's where data or logs would be stored. Finally, I add a management policy to automatically delete blobs older than 30 days, giving you a zero maintenance cost-free retention policy. At the very bottom, we have output. These are like status messages. Once Terraform finishes running, they provide you information so you can quickly confirm everything deployed successfully. Now, it's time to run the build. Inside VS Code terminal, will execute 3 commands one at a time. The first one is Terraform init. The second one is Terraform validate. And the third one is applying auto approve. Now that Terraform has finished, let's verify everything. Head over to Azure Portal, open resource groups, and you see our new group, Mini Infrastructure as a Code Azure Demo. Inside it are all the components we defined, the virtual network, its subnet, the network security group, and the storage account with the private logs container. Now, everything was created exactly as described in the code. That's the power of declarative infrastructure. And to keep this project 100% free, we'll remove it once we're done by running Terraform destroy. Terraform then tears it all down cleanly, which is the beauty of infrastructure as a code. You can spin up or shut down an entire environment in minutes with zero manual cleanup. And that's it, a fully automated free tier mini enterprise infrastructure in Azure built entirely with Terraform. You've just seen how to structure a clean professional infrastructure as a code project, provision secure network and storage layer, and align Azure concepts with AWS for cross-cloud understanding. And this is exactly where most enterprise environments start, a foundational layer that later scales up to include workload, SIEM collector, or monitoring stacks like Azure Sentinel. If you found this helpful, hit the like, subscribe, and check out the GitHub repo. Try it yourself. I'm Jibril Anifowoshe. Thanks for watching. I'll see you in the next